Hello everyone, welcome back to the channel. In this video, we will be discussing about the third problem of today's weekly contest, replace elements in an array. But instead of discussing the actual problem, we will also be discussing a hard version of this problem wherein this statement doesn't hold true. So we will look at why these statements make this problem easier and why removal of this statement would make the problem a little bit harder and what would be the solution of that harder problem. So stay tuned to the very end of the video. Let's start. So the problem states that we are given an array nums that contains n distinct positive integers and we have to apply m number of operations to this array. Okay, so the ith operation denotes that we need to replace the number operations I0 with operations I1. Okay, and it is guaranteed that after ith operations, these two statements will hold true. So let's try to understand this with an example. Like finally, we have to just return the array after all these modifications. So let's try to understand this with an example. Now, let's say this is your array 1 2 4 6 8 7 3. Now your first operation is replace 3 with 4. So what did you do? Like you replaced this 3 with 4. Now let's say the second operation is replace 6 with 4. So you just replaced this 6 with 4. Similarly, the third operation states that replace 4 with 7. So you replaced this 4 with 7. Okay. And now let's say the last operation says that replaced. So basically, like these are also fours. So these are also replaced with sevens. And similarly, there are now four sevens in this array. Now you said to replace 7 with 2. So you have to replace these two as well as these two. Okay, so final array would become 1 triple 2 8 double 2. So this is what you have to, like, this is the final array that you have to return as an answer. So now let's just discuss about the time complexity of this brute force solution. Like if after every operation you go through the array and try to change the elements to the corresponding required target element. So here we see like there can be more than one possible elements that are switched after you apply the operation. So if you look at it in a brute manner, the time complexity would be order n per operation, right? Because you can see that here we have to apply, like, for replacing 4 with 7 we have to replace these three elements. This There are three fours in the previous array, so we have to replace three elements. Similarly here we have to replace four elements, so there can be cases wherein we have to replace order n amount of elements, like the number of elements that we will be removing is in order n. So that's where, like, order n is the required time for one remove, like for one replacement. So there are m possible number of operations. So in total, the time complexity would be order nm if we do this. So this surely would not pass because n and m are both bigger in the constraints. So n and m are both 10 to the power 5. So now this problem can still be solved in brute force manner in the original question because of the statements. So if you remember, we have these two statements that are given to us that will be true for each operation. So what we have given is array will consist of n distinct positive integers. So there all the elements in the initial array is distinct, and then we are given that operations I0 will exist, so that's okay, like the number that we want to replace will exist. Operation I1 will not exist. So what does it mean? It means that whenever we replace an element with a new, like with an element, the array will still contain distinct positive integers. So let's say the array contains, let's say, four distinct integers, so 1 2 3 4. Okay, now like we have an operation wherein operation I0 will exist in num. Let's say the operation I0 is 3. So what they are saying is this will be something that will not exist in num. So it means that it will be the it will be one of the numbers which is not definitely 1 2 3 and 4. So it can be 5 6 7 8 or anything like that, but it will not be 1 2 3 or 4. So it means that your element, like if you remove this 3 and replace it with an element which is not there in this array, you will be getting an element which will have again distinct positive integers. So this statement will hold true after every operation that you will apply. So because of this statement, what is happening is with each operation, you are 100% sure that this, like the replacement will happen on exactly one element. Because the replacement is happening on exactly one element, for each operation you will be requiring order one time if you store the position of that element, and there will be m number of operations, so you will be able to do the entire thing in order m time. So let's just try to counter this with this example. So what happens, like initially the like the number of the elements in, like the elements in the array is distinct, so that condition holds true. Second, like the next two conditions where operation I0 will exist and operation I1 doesn't exist in the num. So because of the second condition, like we haven't followed the second condition here. See, we are replacing 3 with 4. So 4 is something that already exists in the array, right? So we like that this kind of operation will never come in the given problem. So that's where we will not be like requiring this order n time to do this. Instead, if we just store the positions in a data structure or in a number vector, you can easily do this in order one time because you know there is exactly one element which have that particular value. And now because you have done this in order one time, the like or n will be removed from the complexity. So that's what the original problem states, and that's how you will solve this, and it's easier. But now let's try to solve this particular version of the problem wherein this is not there. So basically operation I1 can exist. So whatever we saw here, that this can be possible. So let's try to dive into that. So first observation is that, like look at this sequence of operations that we have performed. We are saying replacing 3 with 4, so we just replaced this 3 with 4. That's fine. Now if we have replaced this 3 with 4, these whatever 4s were there initially are now grouped, right? Because these two 4s will always be changed together. So if you are changing 4 to something, these two 4 will be changing together. So that's what you have done. What you can, like, basically if you are changing something to something else that actually exists in the array, you are forming a group, and further you are saying that this group will not be broken anymore. So basically, if we have to answer this question, that if two numbers become same at any given point of time, they will never diverge. Because if these two fours, like if these two positions become 4, then these two positions will always be same no matter what. So this, like, let's say you change, like when think of the scenario wherein these two positions will change. These two positions will only change when you will have a query that is changing 4. So whenever there is a query that will change 4, these two will change together, right? So this is an important observation. So what we have saying is, if two numbers become same at any given point of time, they forms a group, and this group will be there till the very end of the life cycle of this entire operations. So basically we are forming groups, and that groups remains till the life cycle of the operation. So what we need actually, so let's just continue in this example. So we make this to 4. Now we make 6 to 4, so that's okay. We make 6 to 4, so there are like these three fours that is now a group. Now we make 8 to 1, so we make this 8 to 1. Now these two 1 are exactly a group. Now we make 2 to 1, so these three ones are in a single group now. Okay, now we make 7 to 1. So what we are saying is we are merging these two groups. So every operation is kind of merging some groups. So think of it like this. So there are like there is one 3 initially. 3 is a single group, and there is one 4 initially. 4 is a single group. Now we say that change 3 to 4. So what we are saying is merge the group of 3 with the group of 4, right? We can say this. So similarly, 6 to 4, 6 is a group, 4 is a group of 2. So what we said that merge these two groups. So basically we merge these 6 groups into one single group. Now, similarly, if we have to change this 7 to 1, what we are saying is merge the group of 7 with the group of 1. So that's where like this entire thing will become a single group. So now whenever an operation will come, like let's say change 1 to 5, these all things will change in a go. So hope you're getting what we are trying to do here. So what we want like is a data structure that can merge. So first of all, we need to represent this group efficiently, and what we need is a data structure that can merge these two groups efficiently. Like obviously in less than order n time, because if it takes order n time to merge two groups, in each operation we will be requiring order n time. So our complexity will again be n into m. That's what we don't want. So what we want is a data structure that can merge two groups efficiently in less than order n time. Now if you think of this like our group, once a group is formed, it is never be broken. So this is exactly the property of a DSU, disjoint set union data structure, right? So DSU can do this efficiently, and it does exactly this. So I assume now, from now onwards, if I assume that you know DSU, if even if you don't know DSU, you can still watch the rest of the video. You can treat DSU as a black box that is giving you this power, merging two groups of elements in a single group in less than order n time. You can think of DSU as a black box that can give you this power, and you can continue solving the rest of the problem. If you want me to create a video for DSU and why time complexity is less than order n, I will be happy to do that if there are enough demand. So please comment them. I will record that. So now what we have done is we now know that we want a DSU data structure that will perform these merges efficiently. So now we have everything that we need. Let's try to solve this. Let's try to solve, like, think of an example and complete this. So initially every group. So this is the initial thing. Initially the value is itself. So 2, the value of 2 is 2, value of 3 is 3. Like there is no doubt in that initially. After that 2 becomes 3, 3 becomes 4, and there are like a lot of operations happening after this fact. But initially every element is its own, is forming a own group. Now we we can like we let's say like there are like there is a group. Let's say this is the group. So we want to denote this group by some ID, right? Like otherwise, if you if you make a group and if you want to merge two groups, how will you say that I want to merge group A with group B? So this group A and group B are kind of identifiers of the group, right? So that's what is leader. So we will choose a leader for each group. So this is no different than normal DSU structure. I'm just trying to call it out. So basically every group, like everyone is leader of its own group. So they initially, like there are, like you can see 8. We are assuming that there can be up to like numbers up till 8. There will not be numbers greater than 8. So we have 8 groups, and each group contains only one element, that is itself. So one, like there is a group which contains only one, and the leader of that group is one. Similarly, there is a group which contains only two, and leader of that group is two. Now we also need this mapping, like which leader, which value is with which leader. So we will look at why we need this. Let's start. So this is the initial array. Now let's say the first operation come, change 3 to 4. So when we are changing 3 to 4, what we are saying is we are merging group of 3 with group of 4. So whatever value will be there, like whatever numbers will have which have value 3 will be changed to 4. So what we are saying, just merge these two group, right? And remember, we when we merge these two group, 3 now becomes 4. So from now onwards, if someone says that I want to change 3 to something, that 3 is not this 3. uh, to like make this point again clear, we have changed all the threes to fours, right? So there is no 3 in here. So now from this time onwards, if someone says that okay, I want to change, let's say someone like the next operation is change 7 to 3. So if you change 7 to 3, and now next, let's say the next operation is change 3 to 5. So this 3, like this 3 only denotes this 3. This 3 will not denote the previous 3's, right? So that's where we require this mapping. Basically what we what we want to know is what which value is belongs to which leader. So initially everyone is leader of itself, right? Now when we merge 3 and 4, like we change 3 to 4, what we are saying is there is no more 3 in the array. So there is no group which will, like there is no group which has value 3, and there will be a group which will have value 4, and the leader of that group is 4. So basically we are saying that the leader of this group is 4. We can also say that leader of this group is 3, but that's fine. So now let's move ahead. We have performed this operation and this is the state. Now let's say we perform change 6 to 4. So now if we change 6 to 4, we are again saying that merge this group with this group, right? So what we will do, we will simply merge these two. Okay. Now, if we are merging these two, let's say somehow the leader of the group becomes 6. Like anyone can be leader. Let's say the leader of the group is 6. So we say, notice we have changed 6 to 4. So there is no more 6 in the array, and like there is no more 6. And we have changed 6 to 4. So 4 is like there is 4, but the leader of the 4 is not now 4. The leader of the 4 is now 6. Okay. So that's what array is. So now let's say we changed 4 to 7. So we want to change 4 to 7. So there is 4, right? And there is 7. So basically now we have two groups, one which has leader 6 and another one which has leader 7. So this is the first group and this is the second group. So we now need to merge these two groups. So let's do that. Let's merge these four elements. Okay. And now let's say the leader of entire thing again becomes 4. So what we will do, we will like we move 4 to 7, right? So there is no more 4 in our array. So there is no more 4. There is 7, but the leader of this 7 is actually 4. Okay, so hope you are getting what we are trying to do here. So now let's say 8 to 1, we have to we have to just change 8 to 1. So again there is two group, one with leader 1, one with leader 8. Just merge these two group. So we will merge this 8 and 1. So hope you get the intuition. Let's say like these three operations are not there and we was just want to find out the answer. So we have done all these things, but we haven't find out this array at all, right? So what we want actually is to find out the answer. So what will be the answer? Now we will iterate over this array, initial array 1, 2, 4, 6, 8, 7, 3, and we'll try somehow use whatever we have to find this. So one, let's start with 1. So if we start with 1, what is the actual parent, like what is the actual leader of the group in which 1 belongs? So if we start with 1, 1 belongs to a group whose leader is 1. So leader is 1. So now what is the value of like leader 1? So value of leader 1 is 1. So that's where 1 will be mapped to 1. Now 2, similarly 2 belongs to a group which has leader 2. Now leader 2, we will look at leader 2, and what is the value of leader 2? It is 2. So that's where we map 2. Now 4, it is interesting. So 4 belongs to a group which has leader 4. So now leader 4 is actually has value 7. So we change 4 to 7. Now 6. 6 belongs to a group which has leader 4 and leader 4 has value 7. So we again change 6 to 7. 8 belongs to a group which has leader 8 and 8 has value 8. So we haven't changed 8. Similarly 7 belongs to a group which has leader 4 and 4 has value 7. So that's where this 7 is 7. Now last is 3. 3 belongs to a group which has leader 4 and leader 4 value is 7. So 3 becomes 7. So hope you get what we are trying to do here. If you still have some doubt, please rewind the past 5 to 7 minutes of the video and rewatch this part. What we are actually trying to do, we are basically grouping like we are making groups and we are merging these two groups. That's the only operation that we are performing. Now while merging the groups, there can be cases wherein we are like which two groups to merge is something that will find out using this array. So basically if let's say uh, we are said that like change 7 to 1, so we will find what is the leader of actual 7. Like 7 is a value, that's fine, but 7 has some leader. It might have been merged with something, right? So 7 has some leader. So find the leader of these two, 7 and 1, and just merge these two things into a single one. And because you have changed all the 7s to 1, so there will no more 7, there will no more be a 7. So that's where like there is no leader of 7 because there is no 7 at all in the final hypothetical array. And every for 1, the new leader, like after merging 7 and 1, there will be a new leader, and that new leader you will just assign to 1. So hope this entire thing is clear. Now let's just quickly look at the code. So the code is simple. This is the DSU. So just think of like no need to worry about what is actually there. Just think of it as you can find who is the leader. So parent is nothing but leader. So you can call this function for a particular value and you will get what is the leader. For merge, you will call these two with two values and it will merge that two groups and give you the new leader. Now what we are doing, whose value is nothing but this which value in this example. So that will give you what is the leader of a particular. So initially everyone is leader of itself. Now as and when operation comes to change from to to, we choose like we find out the value, the leaders of this from and to, like leaders of from and to, and we see if from is -1. Basically there is no leader of -1. So there is no group, like there is no group at all which has this value from. So this will not come as per the question because question states that operation I0 will exist. So that it is just for safety check, like we don't need to do anything because it is saying that change 3 to 4, but 3 itself doesn't exist. So you don't need to do anything. Now second thing is there can be cases that who's to, like if that's not the case, you know for sure that you will be changing this from to something to. So this who's of from will be -1. Like there will not be any more from in your array. Now there can be cases where whose of 2 is -1. Basically the thing that you are trying to change is -1. Basically that doesn't exist at all in the array. So if that doesn't exist at all in the array, you can simply, you don't need to merge anything, right? Because there is only one group who's a, like that is the parent of, like that is the group of from, and you just you want to merge it with something that doesn't exist. So that is the new thing, and there like you don't need to do anything. That's the new leader. You just change the value. The value was previously from, you just change it to 2. Now if there are two groups, like these two are not -1, basically there are two leaders, then you will merge those two leaders and you will get a new leader from this merge function and you assign it to 2. So basically the value of 2 is pointing to a leader, to a group whose leader is this. So after you do all this, what you will do, you will like you if you remember how we make this array from this array, we first find out which group this belongs to, what is the leader, and then we find out for that leader what is the value. So we are finding out for that leader what is the value, right? So that's what I have done. Like what is the value I have calculated this previously, and then I just find out the leader of this. Remember, parent gives the leader. I find out the leader of this and then just replaced it with this value. So hope this is clear. Like it exists, it exceeds the time complexity because the it is actually not like it is linear, but the complexity is a little bit strict, as you know in late code it happens. But it actually passes 70 test cases. There were total 75 test cases. It passes 70. It means the actual algorithm is correct. So if you have any doubts in this entire solution, please feel free to comment them in the comment section below. I will answer them. If you like the content, give it a thumbs up and do subscribe if you haven't already. Thank you.